Elasticity and Strength of Bones. By Assistant Professor of Medical Physics, Dr. Al-Arif.
Elasticity. Elasticity is a property of a material that tends to return to the original shape or length after the removal of the force acting upon it. Force can damaging bones and tissues if it comes greater than the elasticity limits. Elasticity related to stress and strain. Tensile stress, S. It is the ratio of the applied force over the surface area of the body part exposed to the force as in the equation. Tensile strain, St. It is the fractional change in length of the material due to the applied stress and is given by the ratio of the change in length, delta L, to the initial length, L, as in the equation. Note: stress represent the action and strain represent the reaction according to Newton's third law, Young modulus, Y. It is a constant depend on the material type which representing of the ratio of the stress to the strain and is given by the following equation. The below table shows some values for Young modulus and the limits for rupture strength for some solid materials, muscles, tendon and bones. The elastic limits. It is the maximum stress that can be applied to the substance before it becomes permanently deformed. The figure shows the relationships between stress and strain. A straight linear relation is observed until we reach the elastic limit point at certain value of stress. This value depends on the type of material. If stress increased above this point, deformation in shape or size happen until we reach the breaking point above which the stress will make fracture in the material. Force and bone fracture. According to the definition of the Young modulus, the force that can cause fracture in the bone is given by the following equation. Accordingly, the amount of energy required to break a bone of area, A, and length, L, is given by the following equation. Clearly the energy is inversely proportional with the Young modulus. The impulsive force. During an accident a large force developed and transferred in a very short period of time between the collided objects. The force starts from zero, increases to some maximum value, and then decreases to zero again. The time interval, delta t, during which the impulsive force acts on the body is the duration of the collision and it is very short. Impulsive force can damage the body. The average value of the impulsive force F, average, is related to the change in momentum, delta p, and is given by the ratio of delta p over the time period, delta t, as in the equation. In the equation, v is the initial momentum of the object, and mvf is the final momentum after the collision. As the time duration decreases, more force will be developed. As the velocity at impact increases, more force will be developed. Bone fracture during fall. When a person falls from height h, his initial velocity is 0, v equals 0. The velocity at time of impact with the ground is v, finial, neglecting air resistance, is given by the kinematic equations as follows. The change in momentum at time of impact is given by the following equation. Then the average impact force developed is calculated as the ratio of delta p over the delta t, and given as. Accordingly, if the impact surface is hard, such as concrete, and the person falls with his joints rigidly locked, the collision time is estimated to be about 0.02 seconds. This time is enough to develop impulse force. The impact time increases when the knees is bend. Remember the pressure that cause a bone fracture is 10 to the power of 9 dyne per centimeter square. If the person falls flat on his heels, the area of impact is about 2 centimeters square. The force F, B, that cause fracture is given by the height, h, of fall that produce such an impulsive force, and bone fracture is therefore given by the following equation.
Whiplash injury. Neck bones are rather delicate and can be fractured by even a moderate force. Fortunately, the neck muscles are relatively strong and are capable of absorbing a considerable amount of energy. If, however, at collision, the body is accelerated in the forward direction by the back of the seat, and the unsupported neck is then suddenly moved back at full speed. Here the muscles do not respond fast enough and all the energy developed is absorbed by the neck bones, causing the well-known whiplash injury. The following is a solved example, please try to follow the solution. The following is a solved example, please try to follow the solution. The following is a solved example, please try to follow the solution.